You're listening to the Maker's Quest podcast. I'm Brian Benham.
And I am Greg Porter. And today we're going to talk about what pieces and parts of millwrighting may apply to our home workshops. And for those of you out there who may not know a lot about what a millwright is or what they do, generally what a millwright does is they go into a factory and they commission different pieces of an operation, whatever those pieces of the process are. They can be tools, they can be conveyor belts, they can be work tables, you name it. But they set things up for trueness, flatness, squareness, plumbness, all of those things to make sure that if you're going to have a repetitive task, that repetitive task is done as accurately as it can be over the course of time. So for instance, a lot of businesses will get a new large machine of some kind, and it has to fit into an existing workflow. So you want the height of that machine to be right, to be able to transfer materials back and forth. You want it to be level so that things aren't sliding off of it. And you want it to be as true as possible. And sometimes in our world, we can talk about table saw fence accuracy. Do you want it parallel and true to the blade, or do you want it slightly tilted out? You definitely don't want it slightly tilted in. But millwrights are sort of the purveyors of accuracy when it comes to setting up any type of machinery. And what I would say is most of us don't have a factory in our home workshops, but we are doing a lot of things in batches, and we're doing a lot of things repetitively that mimic what you would see in a factory if you had somebody spending 8 hours a day at the same machine and doing the same task. So today we just want to talk a little bit about where maybe some of those priorities are in our shops, where the important things are, and maybe where some of the less important things are that maybe we don't need to worry so much about. So I'll start, Brian, by asking you a question. And that question is, first, how long do you spend when you get a new tool making sure that it's level and true with the other surfaces inside your shop?
I don't really worry too much about whether it's level with other surfaces other than what the surfaces that it directly interacts with. Like my outfeed table for my table saw is pretty level, maybe just a tiny little bit lower because I never want it to catch, but I try to make it pretty level so that way if I'm running a dado on a long board and that long board starts to tip down onto the outfeed table, and if the outfeed table is a little bit lower, then all of a sudden my dado starts to tip too and ends up being shallower. But as far as the rest of the tools, I don't so much worry about it because my shop's big enough that there's not really a lot of overlap for things. And that's to a certain extent. Like my bandsaw table is higher than my table saw table, and my bandsaw is at the end of my table saw, but anything I pass over my bandsaw is going the other direction. So it passes over the table saw, and anything that's passing over the table saw is going perpendicular to that. And so it's never interacts with each other. They may occupy the same airspace, like they have the same air rights, but they never, but they're like we're flying New York real estate or something, but they never touch each other. There's no way that any workpiece is going to bump into the other tool.
Well, I guess I'll back up then. You mentioned the table saw, and I think for a lot of people out there, the table saw sits at the center of our operations in a woodworking shop, in a woodworking environment. So when you got the table saw that you have now, which if I remember right is a Delta Unisaw,
Yeah.
which I'm not going to lie, I'm slightly jealous that you have one now and I do not, but we all make decisions in life. But how long did you spend with that saw? Did you buy it brand new or did you buy it secondhand? And then how long did you take to get it level and true to itself?
Yeah, so that one I bought brand new, and when I first got it, that was over 20 years ago now. So I was not nearly as experienced as I am today. So I took it out of the box and set it up and went to work. I spent very little time dialing it in just because at that time I didn't really have the knowledge of how to dial it in. And out of the box, it worked pretty good. But then as I started to use it more and learn more, I started to notice things that, hey, why am I not getting the cut quality I want? And then from there, I started to dial it in. And then after I moved, I had to take the whole thing apart to move it to the new location. And so when I set it back up, I really went over everything to dial it all in 100%. And it did make a huge difference in the accuracy of the saw to have it,
So,
everything dialed in.
so when you're talking about dialing it in, are you talking about leveling and cross leveling the tabletop, or are you talking about adjusting the parallelism of the um, I'm trying to think of what the right term is, the slots in the table to the blade, the fence to the blade, etc.
Yeah, less concerned on a table saw whether it's perfectly level because that's not gonna affect how the saw operates. Um, for that main cabinet. Now, the outfeed table and then I have a table on the wing. I did make sure not necessarily that it was level because most garages kind of slope, but that it
Yep.
was in plane. I think would be a better term for what I was trying to do. So made sure everything was in plane with each other. And then I went to make sure all the table blade was perfectly aligned with the slot, and then made sure the slot was perfectly aligned with the fence. And I know that there's a lot of guys that say that they make their fence just a tiny little bit out because they think it's safer to prevent kickbacks and things. But I think it's a sacrifice on accuracy when you get into like cutting the cheeks of tenons and things. Like if you set up a dado blade and you butt your workpiece up against the fence and you're run it across, run your workpiece to cut off the shoulder, and then you rotate the piece up and then go again, then rotate the piece up and go again. Since the back of the blade is further away from the fence than it is at the front of the blade now, even if it's just a tiny little bit, that tiny little bit gets compounded as you get all the way around, and all of a sudden, all of your shoulders no longer line up for your tenon, and you end up with a gappy looking work. So I made sure that was one of the things that I learned early on why I wasn't getting the good results. And so now I make sure that everything is as perfect as I can get.
I think a small amendment to your fence alignment statement there. I know, yes, the five cut method, the Young G five cut method becomes very apparent when you're doing precision work. It gets so much more important, and that that angle of a fence will stand out. Like you'll notice it almost immediately once you flip a piece around 360 degrees and make the same cut. It'll be very apparent that something's wrong. I think the advent of the riving knife has also made that I'm not going to say a non-issue. Kickback is still a real thing. You have to be very concerned about it. You have to be very conscious of it, when it's going to happen, or predicting when it's going to happen or when it could happen, and making sure you don't get into a situation where you're going to be a victim of a kickback. But I would agree, you can, with a riving knife, I think you can take a little bit more, not risk, that's probably the wrong word, but you can adjust that fence much closer than without a riving knife. I think without a riving knife, you do run a much higher risk of running something into the back of the blade that doesn't belong there.
Yeah, and the saw that I have is old enough to where it that was kind of before riving knives were a big
Yeah.
deal, and they had that old style splitter with the little teeth that fall down, which is always in the way. So like as soon as I set the saw up and then realized that that thing is just in the way, and that's why Norm never used it, and he just put a
Yeah.
little thing on the screen that said guard removed for video clarity. No, the reality is the guard was removed because it's a pain in the butt. So he got rid of that.
Yeah. Well, uh, thinking along those lines, I want to go back to maybe some of the techniques that you used to align your miter slots. That was the word I was looking for earlier.
Mhm.
Your miter slots to your fence. What method did you use to measure that type of alignment? Because I think that is probably, my opinion, the most important priority on setting up a table saw.
Yeah, so I used the single tooth method and a combination square. So I slid my square up until it just kissed the tooth, and then I slid the square back in the slot and rotated that same tooth back until to make sure it kissed it on the backside and adjusted as needed. And then as I got more experienced, I bought a dial indicator to where I can just do that same thing with the dial indicator and it's a lot more accurate. But I wasn't very far out with just a few thou. Um,
Yeah.
so not anything that would make a huge difference, I think.
That was going to be my guess. If we figure that a piece of paper is about 3 thousandths of an inch thick, you can definitely get within that tolerance. Then it's a matter of, is it 2 thousandths, is it 1 thousandth, or is it under a thou? And once you're under a thou, you're cutting about as accurate as a table saw can cut when you figure in the blade wiggle and
Yeah, the
uh,
run out and all that stuff.
dust. that's
Dust,
a
yeah.
that's another one that machinists very much take that into account. I mean, there's a constant, if you look around any machinist doing precision work, there's usually a bottle of Windex and a huge roll of paper towels, and the paper towels, they run through them very, very quickly because one speck of dust will take you out of tolerance in a lot of situations with machining. If you're plus or minus 1 thou or plus or minus half a thousandths, a speck of dust will definitely throw you off. But in the woodworking environment, we rarely think of, and I'm not going to say that we don't clear it off with a broom, but we don't break out the paper towels and Windex to get that type of accuracy. And some of it is the nature of the material itself, but it is interesting when you start to look at some of those things that compound tolerance issues, what those are, and dust is definitely one of them.
Yeah, and I think that brings up a good point that you want to be aware of what your end result tolerances need to be for the part you're making, and then also what the tolerances of the material you're using. Because, right,
Yep.
like you can machine stainless steel down to micron thousandths or whatever. I don't even know the terminology for that. But if you try to do that to wood, and then you go take a lunch break and you come back and a thunderstorm had rolled through,
Yeah.
it's not going to be anywhere near the same because wood is always moving.
Yeah. And on top of that, just adding glue, any kind of glue to a joint, all of a sudden you go from a tight joint to a joint that won't fit any longer,
Yeah.
or you go from a snug joint to a tight joint. And so, people often say that in woodworking you don't need to be down to that thousandth of an inch, but I can tell you, when you're setting your machinery up, when you're setting your equipment up for the very first time, we have, if you have a dial indicator, it's nothing to get within a thousandth of an inch. Like you can see it. The gap on the meter is what,
It's a
three
whole
or
tick
four,
mark. Yeah.
yeah, 3 or 4 fingernails wide till you get to the next one. So you can definitely get within half a thousandths fairly easily. You can dial it in even closer than that if you want to. And it doesn't really take that much more time, right? It's a couple more whacks with a rubber mallet when you tighten things up. And there's a great reminder. If you're setting your table saw up and you're loosening those 4 big bolts that hold the top of the table saw to the cabinet itself, as you tighten those bolts, you can actually take it out of tolerance. So to measure it, tighten, usually you leave one corner tight and then the other 3 bolts are loose. As you tighten them, make sure that you're remeasuring. And if you happen to slip back out of tolerance, just tap it back in with that rubber mallet. Because, and I think you'll agree with this, Brian. You do that one time and you don't really, it might be 10 years before you have to do it again because something happened. You dropped something heavy, or for some reason you had to tip your table saw over
Or a
to
big
clean.
kickback.
Yeah. Or a kickback. Something happens, right? You've got a clog in your dust collection or something, and you tip it over and you realize, oh shoot, now I'm back out of tolerance. Or uh, my favorite is you cut into your table saw fence and you have to replace the faceboard, or it delaminates if it's an old Biesermeyer style that made out of plywood. They delaminate over time. You have to change that out. Well, then get out all your tools and start over. But you can easily go a decade, maybe longer, between the time you adjust it and the time you need to readjust it. And so really taking that extra 30 minutes or hour to make sure it's as perfect as you can get it will pay off in spades.
Yeah, and then I think before we move on from the table saw, we should
Yeah.
also talk about wear points on like the miter
Mm,
gauges and the fence. So
yeah.
my blade has stayed perfectly in line with the slots, but that's a very metal mechanical thing. But the fence has these little neoprene glides on it, and those have worn down over time. So I've had to readjust the fence. And then the miter gauge has little neoprene bumpers inside that when you tighten some kind of hex nut in there, it spreads it out, but then that pushes pressure, and so then they wear again. And so those are constantly needing to be replaced and readjusted.
And you're a much more frequent user of your shop than I. You do this full time. You're not a home gamer. You're a pro. So what would you say? How often do you go through those two items, the pads on the fence and the pads on the miter gauge? Is that once a year or once every 6 months?
Well, the pads on the miter, not let me rephrase that. The pads on the fence are still the original pads because they're
Yes.
pretty thick. So they just keep wearing and wearing and wearing. And you just keep adjusting as you go. The little round discs in the miter, and I have the Incra HD miter gauge. Those little neoprene discs I've replaced once in the last 5 years that I can remember. But I also rotate them. So you pop them out and rotate it around and then reattach to a new round surface. So you can move them around in the jig or rotate them around till you have a new fresh surface and keep on going. But I have to adjust those guys probably every couple of weeks because it wears down that much just
That
from
quickly.
like you
Okay.
pushing the miter gauge back and forth 1,000 cuts in a couple of weeks. All right, that wears pretty quick.
And I think, we both mentioned the table saw fence, the angle of the table saw fence to the blade. And I think we're talking like uh the flat angle, of the table, where there's also is the table saw fence square to the table. So vertically square to the table. And those adjustments that you just mentioned, Brian, I feel like that's where I see it more quickly, if you will, is one side will wear more than the other for one reason. I'm not exactly sure what that is. I'm guessing as you drag it one direction, it wears on one side, and you drag it the other direction, it wears on the other side, or you get a little dust or dirt buildup. I've actually I know I take my fence out once in a while and clean those pads because any
Hmm.
dirt that gets on, I guess it's not the surface of the table saw, it's the surface of the fence, uh, gets on those pads.
Yeah, and the vertical alignment of the fence itself is not something I spend a lot of time adjusting because I shouldn't say I don't rarely because that's a double negative, but I
Yeah.
rarely reference that vertical fence in my work. If
Okay.
I was doing I can't even really think of a thing where I'd be super accurate, where I need to be super accurate vertically. Because most of the time when I stand a piece up, it's because I'm making a decorative cut and it doesn't have to be super accurate. So I
Okay.
could tell you right now, mine is not perfectly aligned, but if I had an operation where it needed to be, like if I was standing, I guess if I was standing a board up to cut the tenon cheeks off,
Mhm.
I would do that. But I think I've discovered that that's not as accurate as laying it down on the table, and so I don't do it that way anymore.
And I'll beat the table saw up with one more detail. One of the things that, and unlike you, Brian, I'd spent an insane amount of time getting my table saw level, and a couple reasons. One of them is because my garage floor, and you've been in my shop, my floor is very, I think I have 11 or 12 inches of slope on my floor over 20 feet. Like it is a massive incline. So I have to spend time leveling whether I want to or not, or my tools will just roll down the hill. But I have an extension, a router extension on my table saw. I make instruments, and I need my table saw surface and my extension to be perfectly level with one another and coplanar. I should say coplanar, not necessarily level. But part of that is making sure that I've got a Biesermeyer style fence, making sure that that big piece of steel tube is coplanar with the top of the table saw and the extension on the router table side of things. And for me, the best way to do that was to get the table saw perfectly level, to get the extension perfectly level, and then adjust their heights up, and then get that fence tubing perfectly level with it as well. And the only way to get that big piece of steel tube coplanar with the table saw top was to make sure they were all perfectly level, because that was my reference, rather than trying to put a big straight edge hanging out and try and measure back and forth there. So anyway, I also I approach things from an instrument maker's perspective, which is a completely different perspective. I'm no longer working with boards that are 6 to 10 inches wide. I'm working with boards that maybe along a 24-inch length. I have to have incredible accuracy over the length of, or over the edge of a curve that's 20 some odd inches long. So totally different
Yeah.
operation. But I can tell you one of the first things I did, for those who don't know, I bought a saw stop a year ago. Did I buy it over Christmas this past year? Maybe I've had it for 8, 9 months now. That sounds about right. I bought it at the end of last year. And I set it up and I thought, yeah, this extension table that came with the saw stop is probably good. And I got it installed and started measuring things, and it was so far out of tolerance, I just threw it right in the trash, because I knew it wasn't going to work for me. And then wound up building a torsion box style router extension, so that I knew that that torsion box was going to be as true as it could possibly be. And then I knew I could shim that torsion box where I needed to shim it and get it true all the way across. So many hours with a precision straight edge and feeler gauges, and that table's pretty good. And I also used what is it, a 5/8 inch thick piece of solid surface on top of it, so that it doesn't move. The saw stop extension was just laminated plywood. So just wasn't going to hold up over time to the tolerance that I needed. So anyway, it was
Yeah.
it was a very interesting dive into precision, I guess, mill writing of lumber, for lack of a better way to put it. But it is impressive, or it is interesting how flat you can get a torsion box in an ordinary shop without a ground steel table to build on top of.
Yeah. Yeah. I wish I would have spent more time on my workbench. My workbench is a torsion box, and over the 8 feet, it is out by about a 16th of an inch, which in furniture making is not a big deal. Most furniture guys don't have a torsion box. They're just building on a sheet of plywood as their assembly table or their workbench that has been hand planed down multiple times. So I'm sure it's probably a little bit on the wavy side. But I do find it really handy to have something that's I can rely on, that's really, really flat, that's large.
Yes, of course. And I my background is more metalworking than it is woodworking, that's for certain. And in metalworking, that type of tolerance is much more important. Welding tables, which I think you've got a Certiflat or a similar type of tab and
A
slot welding table.
Langmeyer, or something like that.
Langmeyer, that's
Yeah.
right. Welding table. And again, very impressive. Those things are cut with lasers, I believe, and you clamp them all together, and it's basically a steel torsion box design. And over the length of a 4-foot table, you can get it within just a few thousandths of an inch across that width, fairly easily. And that type of accuracy will spoil you, especially if you're building things that are very three-dimensional. So long tables with legs that have to be squared up and all those kind of things. When you know that you can reference off the surface of that table and have a very accurate measurement for angle or measurement for length based on, the surface of that table being your reference. That's huge. In the machinist world, you just get bigger and bigger pieces of granite, and and that's how you deal with that operation. So machinists kind of laugh at welders and say that they work very inaccurately, and you just sort of tighten that tolerance as you work your way down into that world. So,
Yeah,
um,
I will say that getting that Langmuir fixture table was an absolute game changer in my work. It made me from a shitty welder to an okay welder. Right. I still have a
yeah,
long ways to go before I can say that I'm a good welder or an excellent welder, but it was life changing, or just how accurate it was, and be able to set up fixtures. Um, and I kind of think about, like, maybe I want that for my woodworking, but then
mhm,
at the same time, not really. Like Festool has an MFT, I think they call it, that's got all the holes in it, and I've
yeah,
used one of those before, and it's just a piece of MDF with holes drilled in it, so stuff gets flexed and holes get wobbled out, and it's just not. I don't think it's feasible for woodworking. I don't think that you'd want to do your woodworking on a steel table, because anything that's on that table is going to get embedded into the grain of your
yeah.
project.
And I'll stick in a plug for my friend Fred. Fred runs a company called Track Tubes, and they have an MFT style table that he sells. I bought one of them not too long ago just to support a friend, but really to understand with a track saw and with some of the other things that are out there, what can you do on that style of table? And I've been impressed. I just use it with a pair of Bora speed horses, I think is what they're called. It's just a
Hmm.
sawhorse that sort of has a release, and then I can set my track tubes on there, and then I can set my MFT top, and all of a sudden I've got my outdoor track saw table just set up that quickly.
Yeah.
It Not a total game changer, but for me in a small shop, I don't have an area to lay down and do miter style cuts. So that's why I bought the track saw. And that one did help, but you're absolutely right. They actually sell a, a reamer for those holes, because the MDF will swell up over time and those holes will close, and all of a sudden you can't even get your pins in. But they sell a reamer for them. There's all kinds of things. That's a whole game. The MFT tops. But back to, you said you're becoming an okay welder. I would change the name. I would say, if you look at it not so much through welding but metalworking, a good table like that, a good setup table, will make you into a good metal worker.
Yeah.
And the welding is one facet of that, but fitting together the steel or the aluminum that you're working on, the better it fits together, the better the whole project is going to be. The easier it is going to be to weld nicely. So everything builds on itself. But yeah, I would say, if there's one thing beginning metal workers should invest in, it's not necessarily a tab and slot Langmuir style table, but a very flat and true steel table will help you tremendously. You can tack things to it, clamp against them, whatever. You can drill your own holes if you know that, say you're doing a production of, you know, 10 tables a month or 10 fill in the blanks a month that have similar measurements. You can drill your own tables and use your own dogs in those holes. And it's amazing how that fixturing and jigging ability will increase the quality of your metalworking very quickly.
Yeah. So I can't think of the name of this plastic, but a lot of tool manufacturers use this hard plastic for fixtures and building jigs and things.
Mhm.
Is that you? Is that
UHMW.
maybe? I thought it was a phenolic, maybe.
Oh
That
yeah, there's some phenolics. They have G numbers to them, I think, like
okay.
G4 and things like that. But yeah,
Yeah.
uh,
So I
it
wonder
smells
if
really bad when you cut it. Yeah.
yeah, I wonder if I could get a big thick piece of that and a CNC machine to bore the holes, if that phenolic resin would hold a fixture in it better than MDF.
It would. And so back to my table saw extension. So it's where my router sits, my router table. I bought a piece of solid surface, which is not phenolic resin, but it's a different kind of resin, but it is pretty darn hard. And the cool thing about it is you can buy it in sheets and it's readily available. Phenolic is probably a different story in terms of price. I want to say phenolic's maybe 3 times the price of solid surface. It's very expensive.
And when you say
Most
solid surface, are you talking like granite or what
it
material is that?
it's a resin material that's poured into sheets.
Oh,
So you can get it, I think you can get it 1/4 inch, 1/2 inch, 3/4 inch on down the line. It sort of runs like plywood, but it's quartz countertop is another word that people use for it. Quartz is there's variations. Silestone is a variation that's a
hmm.
quartz countertop, but solid surface is it's a plastic resin, but it's a very hard plastic resin that sort of looks like granite, but is way less expensive than granite. So it's a good alternative out there for people who want their countertops in their kitchen to have that high end look, but not have to pay the price. The flip side of it is you can machine it with woodworking tools. So you can cut it with a circular saw, a router, fill in the blank, and then you can polish it out and
Hmm.
glues together. So you can have pieces that are 20 feet long and seamless. You can put it in the oven and heat it up and bend it. You can do all kinds of interesting fabrication techniques with solid surface that you can't do with other things. And I just, I'm sort of cheap when it comes to my shop fixtures. And I want to say a sheet of solid surface in the thickness I was looking at, which again, I can't remember, it was a 1/2 inch or 3/4. I think just the sheet was going to be $600, and then the shipping was going to be 200 or 300 bucks because it's so heavy and so large. So I just surfed on Craigslist for somebody getting rid of their old countertops and found somebody who was upgrading from solid surface to granite and selling off big chunks of countertop. So I was able to get a piece of solid surface that was, gosh, it was really large. It filled the whole bed of my truck, and I think I paid like $100 for it. So
Wow.
wound up working really well.
So you still have some left over for other benches and things that you may want to do in the future then.
I do,
Yeah.
and it's been
Nice.
taking up room in my shop, and it has an edge on it, so it's got a, I don't know, a 2 inch thick edge on one side of it. It makes it really awkward because it doesn't want to stack with my other sheet goods. So at some point I need to machine that off so
Oh,
it's
so it
not
has
such a
like a
pain in the.
laminated edge to make the countertop look thicker. Okay,
Yeah,
cool.
that's one of the cool things about solid surface is you can the glues actually melt the plastic together, is how I would say it, so it looks like it's seamless. It's pretty cool. Um, but yeah, so kind of back to our topic of from a millwright perspective, how far do you go? And I want to switch levers for half a second and talk a little bit more on the machining side of things. And this is probably where I get my OCD when it comes to table saw levelness and some other things in the shop. When you set up a milling machine, it's all cast, right? It's all
Hmm.
cast iron. Not some there are other techniques for making the inner guts of those things, but for the most part, your Bridgeport style machines, your Tormax out there, I think even Haas is a cast piece that is the main pillar for everything to operate off of. The interesting thing about those is you have to have them level and true both side to side and front to back, because if you have any twist in that machine, it will cause wear and it will take that machine out of tolerance in a fairly short amount of time. So a machine that is weighing in 1,500, 2,000 pounds, you've got to spend the time to get it within an incredibly small tolerance. And I kind of grabbed one of the tools that you can use to do that work, and it's I don't, of course, we're on YouTube and we're also on other platforms that don't have video, but this is a Starrett 12-inch machinist level. And it will, if you look at the graduations on the level bubble there, they go way out. But what it will do, and of course, we can't show it because it has to lean straight up and down, but it'll get you within five thousandths of an inch over a foot, which is, the thickness of a piece of paper over a foot is the accuracy that that will dial into. And when you're setting your big milling machines up, it's very important to get them in level. So that's kind of where my mind started, because that's what I'm used to doing in terms of setting my own machinery up. And I applied a lot of that again over to the table saw. But, for me, it was not just getting the table saw, but then getting the wings level as well. We all have those table saw extension wings that seem to just drive us nuts, right? If there's just a little bit of a, uh, imbalance, I guess, there, so that it's not completely coplanar. Boy, they'll drive you crazy. If they tip up just a little bit, they can push work either into or away from a saw blade when you don't want it to. It's just those little tiny slip ups that seem to get under our skin that happen, of course, not when you're working with boards that are 6-inch wide, because those are easy. They sit on the main ground table. It's when you're starting to laminate things together and have these big glue ups. And of course, the further you get into a glue up, the more likely a poorly adjusted saw will affect your work. So anyway, interesting stuff. But I've applied that to a lot of things, and of course, welding tables are kind of the same thing. If you can get them level and true, both side to side and front to back, you're going to have a lot better time making sure that those whatever you're welding on top of that table is going to be the same trueness. So I guess switching gears a little bit, there are tools, I think, in both of our shops that are on wheels that we never spend the time to level up and true up. And so maybe it'd be good to talk about what those tools might be and why it's not as important. So I'll let you fire first, Brian.
So I do have a, perfect example of that, but while you were talking, I thought of a question that I want to back up a bit about the
Sure.
level.
Yeah.
So in my world, I reference everything off the tabletop. So even if the tabletop's this way tilted maybe 3 degrees, if I set a square on there, I'm still able to find a 90-degree angle to build from. So in the machining world, what is the gain of leveling the table?
Yeah.
What am I missing in my workflow as a woodworker that I don't know yet?
Well, so okay. This goes into some fun things that we don't always see in woodworking, and we don't always have adjustments for. But uh, so if we start with the table on a milling machine, right? So we have a table that has an XY movement, and then we have a head to the milling machine that has a Z movement, and it's purely vertical, right? There's no other factors there. When when you start measuring tolerance in a milling machine, you're moving the table to its far X limit and measuring the difference from one end to the other end. That tells you, is my table true to the ways, which is what the table runs on. Usually the ways are a dovetail situation. There's linear rails now that people use, and there's some other things. But suffice it to say, if I put an indicator into the spindle of the mill and I run my table back and forth, it'll show hollow spots, or it'll show that one end's high and one end's low. If one end's high and one end's low, then you shim that table up to get it to where the run out is as close to zero as you can get it. And then if you have to re-level your whole machine, you get that level again. You do the same for the y-axis. So that table will run perfectly true to the spindle. Okay. That's the start. Then you start looking at the Z travel, and the Z travel has two different adjustments. One is the nod, and what's the name of the other one? Nod is kind of the forward and backward, and then it's not the lean. Shoot,
Someone will tell us in the comments, I'm
they
sure.
will. They will. Please save me. But you have to have, because sometimes we use fly cutters that are 4 inches in diameter, right? So if my machine is knotted a little forwards or a little backwards, every time you overlap that fly cutter, you're going to see a line in your work. And in the machinist world, a thousandth of an inch, you can totally feel a thousandth, right? Like that'll stop your fingernail. So you're trying to get that knot adjusted on the machine to a point where you're maybe 2/10,000ths of an inch out. That's an acceptable tolerance. So you might ask, well, how do you adjust that, right? And there's nothing in the instruction manual that will tell you anything about these types of adjustments generally. But most people use the cellophane on cigarette packages as a shim material. So that's kind of the level of finesse that we're talking about. So if you can't make the adjustment with that thickness of cellophane, you're probably okay, right? Like if you're within that. So most heads have about, I'll say 12 inches of travel. So you're talking, probably a thousandths shim on a 12-inch travel. So that's a pretty small angle is kind of where I'm going with that. And then yeah, you look at the lean, and most machines, the head bolts in with anywhere from 4 to, call it, a dozen bolts, and you can loosen those bolts and adjust that lean to where it gets perfect. Did that answer your question, Brian?
Yeah,
Sorry, that
so
went way
no,
into the
that's good. So
woods.
basically what I'm gathering is because the table is moving, level is a good way to find all directions so that way you can plumb the tool or the head to whatever level wherever that table's at. If your table's perfectly level, it's not drifting all over the place, that you're going to get a lot of increased accuracy. And I think I've seen similar results in my CNC machine. Like I'm doing a cleanup pass to flatten something, but there's a ridge there, and that's probably because the table is not level, but the CNC travel is traveling level.
Yeah. And it's the same on a CNC router. Um, if you're using a 1/2 inch diameter router bit, it's not going to magnify that problem very much, right? If you do overlapping facing type operations or flattening type operations. But a lot of us with CNC routers have a bit that we use to mill down our not our baseboard, but our what do we call it? Um,
The work surface,
what's it called? There's a
there's a
uh,
name for it. It's the work surface of something.
oh my goodness. I could look it up. It's okay. Um, but when we're surfacing that down, it's the same magnification. Spoil board. There we
Yes,
go. You're
spoilable.
surfacing your spoil board. Most of us have a larger bit that we surface that spoil board with, and that starts to magnify that, right? But you can make the same. It's nod and tilt. I finally got it. So you can make those same nod and tilt adjustments on your router, right? Like it buckles into some kind of apparatus, and you can either shim it or twist it or do whatever you need to do, and really dial that in as well. I know when I got my Avid CNC, that was one of the things I spent a ton of time on, was making sure that the router head was as from a nod and tilt perspective as close as it could be to being perpendicular to my spoil board.
Is that what they call tramming it in?
Tramming it in, it is. And Stupid Simple Tools, or some company, I think it's Stupid Simple Tool, I don't know, one of them makes a dual dial indicator thing that goes in your router spindle that you can spin around and see, am I true to the spoil board. I'm not sure if that's the best possible way to do it or not. I kind of did mine by feel, like just keep running it over a surface and making sure that you're not you don't have a sawtooth pattern, that it's flat and true to the next level. And once that flattens out and there's no ridges, you're kind of where you need to be. So you can do it either way. Um, I think it depends on the rigidity of your machine as well. If you have a Laguna IQ style, those are a lot more rigid machines than an Avid, and I think that Stupid Simple Tools would probably work more. There's no bounce in the spoil board on those types of machines. Is kind of where I'm
Now,
going.
this is assuming that your spoil board is flat. If you put that
Right.
indicator in there, and the
Yeah.
foil board has a warp in it, it's gonna give you a
The,
false reading. I'm skeptical of
yeah.
the validity of that tool. So yeah, so back to your mobile base thing. Yes, a
Yeah.
tool that makes no difference would be that whether it's on a mobile base or not. And before I say that, I will say that I took my table saw off the mobile base and it stays calibrated better, more solid, less problems, especially with the in feed and out feed in the wing. But the tool that doesn't matter whether it's on a mobile base, on it would be the bandsaw. Doesn't matter what you do to a bandsaw, that thing has a spirit that comes alive at night and changes everything. I can spend an entire day, oh, it's dialed in perfect, and then come back the next day. No, piss off is what it says. Yeah.
Yeah. Well, somebody explained to me one time that the heat in the bandsaw blade makes the bandsaw blade change, right? So as you're using it, it heats up. And so the first cut you make on a bandsaw blade is one thing. As half an hour into your bandsaw work, it's a totally different thing. And then when you turn it off and come back the next day, that blade has gone through a heat cycle and shrunk. And so it's no longer the same blade. It's like stepping in a river. You can't step in the same river twice. That you're exactly right.
New blade. And I guess as it's going around the wheel, those big rubber tires are getting hot and
Yep.
cooling down. And yeah.
And the bandsaw has something that not a lot of the other tools have, and that is on the bearings that hold those big wheels. Number one, there's a ton of tension on them to get the bandsaw blade tensioned right, but they have torque and force. Uh, the thing is turning, so there's your radial, but they have axial force in two different axes, both into the wheel and perpendicular to the axle. And so it has every type of force that you could imagine in an angular situation, making it almost impossible to, from a wear perspective, to wear for very long. So yeah, what a difficult tool to tame, no doubt.
Yeah. It's not a tool I ever trust for accuracy, which is I was gonna grab it because yesterday I was resawing some end grain butcher block things, and I was able to resaw pretty repeatedly, um, like thin that I could see through the end grain of the wood. But I was able to take really nice, consistent slices. But that was only for a little while, and then it changed, right? Like all of a sudden now it's like, nope, is the blade dull? Not really. It's a brand new blade, but yeah.
Well,
So slicing veneers is one of those things that I've noticed the frustration is that I can get it dialed in and it does great, and then the next day it doesn't do anything, and I have to redial it all back in.
yeah, the bandsaw might be one of the most frustrating tools in the wood shop. And there are people out there who tell you it should only take 2 minutes to dial in a bandsaw. And that may be true in the situation that they're using it, but when you use a bandsaw as I'll call it a utility player, right? Like it's doing all different types of work in a shop. It's not just set up for one purpose. Uh,
Right.
you start to run into its limitations very quickly. Not necessarily limitations, that's the wrong word, but you run into those frustrations very quickly.
Intricacies.
Yeah.
Yeah, it's two different things, two different setups, two different expectations when you're cutting out reindeer for a decoration
Yeah.
versus resawing veneer that's $1,000 a foot or whatever for real expensive veneers.
Yeah. And I go back to when I look at how do I use my band, I have two band saws, right? I have the normal Delta. I don't know what the measurement on that one is. It's a 12-inch that everybody has. It's the one that you see everywhere. Jet has a version of it.
Mhm.
Powermatic has a version of it, but Delta Rockwell came out with it in the 40s or something. I have that one that always has a 1/4-inch blade in it, and I just use it for shortening pieces of lumber. that's its main job. Or if I have some tight radius work to do, I do it with that machine. And then I have the big, what is it, 19-inch or 21-inch Rikon that has a blade that's like an 1.25 inches or 1.5 inches wide. What I can tell you is the wider the blade, the longer it stays in the tolerance and the adjustment that you want it to be in. The smaller the blade, the higher the chance that it's going to piss you off in a short
Yeah.
amount of time. But that's that. I'm working on that theory. That's my working theory, though.
Yeah. So another tool that I find super frustrating to use that I don't think matters whether it's on a mobile base or stationary or bolted down is like the drum sander. So I'm curious, how many pieces of wood, how many work pieces have you ruined because the drum sander?
Ooh, that's a good question. I can tell you, I changed drum sanders. So I went from, um, my goodness, it was a Delta version, 1632 or whatever, the magic numbers. Nah, not 1630. Yeah, maybe it is. Um, I went from that, and that one, every time I used it, I had to adjust it. It was out of parallel. It would take 10 thousandths of an inch more on one end than it would the other. And God forbid you run a piece through halfway and then flip it around and try and do the other direction, uh, because you were going to have a valley in the middle or you were going to have a hump in the middle, one of the two. But I did switch to a Powermatic version, which is a 2244, I think, has a lot more horsepower and it's cast. So the big arm is cast and it has a very easy to adjust parallelism adjustment on it. And since I bought that machine, I've ruined 0 pieces of work. But before that, it was about every third piece would either over sand it or under sand it, or it would get caught in the middle because I was trying to run 2 or 3 things through and one thing was slightly thicker than the next and it would hold up and burn.
Yeah. Or kick back out. Yeah. Yeah. I have that same problem. Everything I stick through my jet, I have like the 2244 or something like that,
Yeah.
somewhere in that range. I don't know if that's the exact number, but somewhere in that range. And just constantly one side sands more than the other, or something's going on. And so I did get frustrated with it, and I took the belt off, and then I used a dial indicator and plumbed the or leveled the whatever you want to call it, trammed the bed to the head,
Yep.
and 300 times better than it was. A lot less material to go through that exercise of really trying to dial it in. But I still have a lot of problems with the drum getting hot and the
Yep.
paper slipping on the drums and things expanding and contracting in that realm. So it's by far not a perfect tool. I long for the day when I have a large shop where I can get something like a time saver, where
Yeah.
it's like this huge belt, so it has time to cool before it touches the work again.
Yeah, I haven't run into any issues with the Powermatic overheating. I don't know if that's a design thing or if it's just lack of use thing, but I have run quite a bit of ebony, rosewood, those types of things through it, which will just kill a drum sander if you're trying to do too much.
Hmm.
The other nice thing about, and I don't know if the Jet has this or not, but the Powermatic will sense when there's too much torque, and it
Yeah.
will it will automatically kick down a speed and then it'll kick down another speed if it's still going too fast. So there are some things in place on that Powermatic that I do believe help save things that would have otherwise either burnt up or kicked back or gotten snipe in
Hmm.
the middle of a piece because of one thing or another. So I would attribute the fact that I haven't burnt anything up probably to that one control. Although that all comes off a big digital panel, and I know 15 years from now, when that panel burns out and they no longer sell that part, I'll be really upset that it wasn't a mechanical device rather than a digital device.
Yeah. Funny you say that. So just to answer your question, yes, my Jet does have a similar thing. It's not a digital thing. It's just got a red light with a dial, and
Uh,
that's it. It's a very simplified thing. But the whole digital thing, there's a guy on TikTok that I follow that owns a scrap yard, and he had a machine that he ended up selling because it broke down, and it had all the fancy new mechanical stuff. And so now he buys used old machines that don't have the mechanical things, because when it breaks down, he can fix it. He doesn't have to go buy the $1,000 computer program or have the mechanic that has the reader to plug in to find out what's wrong with it. He can just like, hey, I've got years of being a mechanic experience. I can fix my own equipment.
Yeah. So, well, let's talk about adjusting things like a drum sander. Like how do you dial indicate onto a thing that's round and adjust to it? I can tell you if I were in your shop and you said, "Man, Greg, this drum sander just isn't true." How would you like to handle this? I would bring a tool. And I think most people have heard of 1, 2, 3 blocks before. So it's a ground steel block, a precision ground steel block that has one side that's 1 inch, one side that's 2 inches, and then another side that's 3 inches long. And with that block, with a pair of those blocks, you can do an incredibly large amount of setup work without any dial indicators or other fancy tools. And that would be one thing that I would bring with me as a pair of those blocks. And I would set those between the bed and the drum so that you can crank the bed up or the drum down. I don't know which way yours works, but crank it down so that it sits on one side, just makes contact. And then I would adjust the other side in to where it just makes contact as well. And I'll bet you could set that machine up probably in a 10-minute time period and be within probably a thousandth or two without any really difficult work. I don't know. I'm curious how you used your dial indicator to do that.
So yeah, it was a little bit of a mind bender to figure this one out, because I started out with your method of using one of those blocks from Fireball Tools. They're supposed to be
Oh
like
yeah. Hmm.
precision ground or whatever. So I used his block. It wasn't a 1, 2, 3 block, but I used his block to do that. But the thing that I've discovered is as you're tightening it, it's the adjustment on the jet has kind of a
Yeah.
coarse thread, so it's not super fine. So as I was tightening it, if it put pressure on the head would flex because the head's cantilevered. So you can do this whole run half your table through and then turn around and run the other
Yeah.
half of the table through. So it's cantilevered. So I could flex the cantilever a little bit. So what I did is I took my dial indicator, and the particular one that I bought has like these arms that you can build
Hmm.
a jig. So I had it come up off the base, go over a few inches, and then come back down and onto the top of the head. And even though it was round, as long as I was referencing off the same spot on the head, I felt like I was pretty good. So I used a line that I marked on the bed of on the metal plate of the bed that the belt goes on. And I used my like just a very crude way to mark that, just using my ruler and with a pencil, and just ran down the edge of the thing, the drum, ran down the edge of the drum with the pencil dragging on the metal plate. And then that's what I used for my metal plate, or my to set my indicator on the base of the indicator. That also has a little magnet, so it kind of sticks down, and then I was able to move that back and forth.
Okay. And that's what I was going to say. If you're, a lot of people in their home shops don't have a ton of precision equipment, right? But one
Right.
of the things we do have, as for sure as woodworkers, is generally a really good square.
Yeah.
And it's always good to have two squares so that you can put them up against one another and see, am I really square or do I think I'm square? Now, both of them can be out the same amount the wrong way, but there are ways to check against that to make sure that you're square and true. And once you have a square that's good, yeah, you can run it down the face of that drum and like you said, make reference lines with a scribe or some other tool so that your setup is identical from one end to another. But that is critical, especially on a round weird thing. Like, how do you measure this? Um, and a lot of machinists will use things like V blocks on top of round things, and you can measure one side or the other of the V block and get it level. And then that will start to tell you where is the center of this thing, and all of those kind of fun little tricks. I think you can look up a few good tool channels. Tubal Cain is one of them. Randy Richards in the shop has a lot of great machining videos that show you how to measure oddball things, like how do I find the center of a drum, that sort of thing. But that does help tremendously in getting those machines set up
Yeah,
accurately.
I'll say like when we were in school in high school or whatever, we're like, when are we going to ever use this math? And I'll tell
Yeah,
you, geometry is one that I use every day. Calculus, I'm not sure if I could even remember what that was about at this point in my life, but geometry every single day. Because yeah, those V blocks and things like that is a great way is basically just using geometry to figure out your stuff.
yeah. Well, so let's see. One of the other pieces of equipment that I think most of us have, especially if we're woodworkers, is the jointer. And rifling through, do we need to worry about the jointer being level and true? Maybe to our shop floor, but then to itself.
Well, I think the in feed bed and the out feed bed need to be uh is the word coplanar. They need to
Yeah.
be in or
Mhm.
in plane with each other, even though the out feed table is just a tiny bit higher than the in feed table moves depending on how much of a bite you want to take.
Right.
And one day spent a ton of time trying to dial mine in, and mine's not what they call a parallelogram where you have different points. Is basically just one thing where you shim around until you get it dialed in. And it was incredibly frustrating to get it dialed in. And then after I thought I had it dialed in and I started to use it, I was making tapered boards. So I wasn't nearly as dialed in as I thought it was. And so I quit for the day. And then I came back the next day with less frustration and fiddled with it again. And I was like, I'm trying to get it dialed in. And I was like, yeah, this is close enough. I just need to get back to work. I'll deal with if it's not um, plain or whatever, if it's not perfect. And somehow by just saying, oh, this is close enough, it's been perfect ever since. Like I just like
Nice.
accident. Like I don't know. And so now I'm afraid to touch it. I'll never take that thing apart.
Well, I bring that one up because I think that is one piece of equipment that maybe not necessarily frustrates people, but it perplexes people. How does it work? What do I need to do? And really, some quality time with a precision straight edge and a set of feeler gauges will help you across the face of your in feed out feed. So you basically put your straight edge sitting on your out feed, and then you measure to your in feed at a known distance, and you make sure that dimension or yeah, that measurement is the same across the entire face of the in feed, right? So if you're drop down a 32nd of an inch, making sure that you're dropped down exactly a 37th of an inch across, or 32nd of an inch across the entire face of that thing. If it's not, you could run a 3/4 inch wide board up next to the fence all day long and it might be perfect and true. But then when you try and flatten out that 6-inch board and max out your planer knives or your jointer knives, all of a sudden, like you said, you're going to have a twisted or tapered board, and something's not going to be right. The other key adjustment on there is the height of the knives compared to the outfeed table, and they've got to pretty much be spot on, or you're going to snipe the middle of your board as you go. And again, take too
Mhm.
much material or take too little material in the middle or the ends of the boards. Um, so, and then lastly, one of the things about a jointer, right, is the 90 degree, and making sure that cast fence, usually they have a detent on the fence somewhere that locks it in at 90 degrees, but there is an adjustment to make sure that detent is spot on 90. And most of the time, flipping a board end for end and making sure that square is enough to make sure that you're on the nose there.
Yeah, and then if you use like the hand plane technique, even though you're on a jointer, if you joint uh, two bores with one with the face facing the fence, and then the next bore with the face facing towards you, the joint will cancel it out if you're not 100% 90. Um, But I will say that you do want to try to make an effort to get them 90 and not rely on that trick, because then when you go to glue up, when the clamping pressure on two
Yeah.
angled things, the one might slide up on you
Yeah.
and create some clamping frustration.
Yeah, for certain. Well, I'm looking at our time, Brian. I think we've been on here. I think it's been about an hour.
Yeah.
Um, so we've covered a lot of distance. This
Yeah.
has been an interesting conversation. I hope everybody listening has found a little bit of value in here in that, most tools out of the box are not square true and ready to use. You have to mess with them a little bit. I will say kudos to SawStop. When I pulled that sucker out, the miter slots and the parallelism of the miter slots to the table saw blade was perfect. Like I couldn't find any problem there. I was like, wow, this didn't even get dropped by the forklift. This is a good day.
Yeah.
But taking the time, my big point is taking the time, just setting aside a day when you get a new tool to set it up and make it as perfect as you can make it today is really going to pay off in spades for you over the time of that tool ownership. And then having the knowledge to understand maybe a year or two or three into that tool's ownership that, hey, maybe I need to go revisit some of these things and see how close I was. And sometimes you might surprise yourself and be able to dial that tool in even better. And man, that makes such a huge difference.
Yeah, for sure. And then it's one of those things that you don't know what you don't know, right? Like when I first started woodworking, I thought I knew what sharp was. Like I spent a lot of time sharpening my hand planes and chisels. Like, yeah, these are nice and sharp. They're taking nice shavings. And then I went to someone's shop that had more experience than me, and I used one of their hand planes, and I was like, wait, can you show me how you sharpen this? Because this is like a whole nother level of things.
Yeah.
So by not having your tools dialed in, you might not know what you're missing out on.
Yeah, for sure. Well, cool. I guess we'll wrap up there if that's all right.
Yeah.
Um, I am Greg Porter. You can catch me on YouTube at Greg's Garage and Skyscraper Guitars, and the same handles on Instagram.
All right. And I'm Brian Benham, and you can find me pretty much everywhere on the web under Benham Design. Thanks for listening.